Today we will talk about solving quadratics. This isn't much different than the quadratic formula lesson from yesterday. There's just some more wording that I want to talk about. So first of all, sometimes you're asked to find all zeros, or they could be called roots, or they could be called x-intercepts, or they could be called solutions. Any one of these words means the same thing. So find all zeros, etc. of the quadratic function. And to do this, you would just do the quadratic formula. So let's say I gave you 2x squared minus 3x minus 5 equals 0. You just do what we did yesterday. So do me a favor and pause your video and try this, and then I'll show you. Okay, so we have x equals 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times 2 times negative 5, all over 2 times 2, which is 3 plus or minus, this is 9 plus 40, so square root of 49 over 4. This is 3 plus or minus 7 over 4, because the square root of 49 is 7, and then we split it. 3 plus 7 over 4 is 10/4, which simplifies to 5/2. 3 minus 7 over 4 is negative 4 over 4, which is negative 1. So then our answers are x equals 5/2, and x equals negative 1. If we wanted them as points, we could say 5/2, 0, and negative 1, 0. It depends upon the exact wording. But what this really means is that if you were to graph this, there would be x-intercepts at negative 1, let's say that's negative 1, negative 2, 1, 2, at 5/2, which would be about here, and negative 1, which is here. The coefficient is positive, so our function would look something like that. Okay, so that's what zeros, roots, x-intercept solutions are. They're just where the function would cross the x-axis. Another type of question you might be asked is find the zeros, or roots, or solutions, or x-intercepts, etc. Find the zeros using your graphing calculator. And let's say our function is x squared plus 4x plus 3. So first of all, zeros is setting this function equal to 0. Whenever you solve a quadratic, that's what you're doing. You're setting it equal to 0. And so here are options. So typically on a test, you obviously wouldn't be able to use Desmos or anything, but since we're online, you can use Desmos whenever you want. So if you look right here, if I put in the function, let's see if I can, yep, I can move this over. If I put in the function y equals x squared plus 4x plus 3, you can see here, and Desmos is really nice because it kind of gives you everything. So you can see the zeros are at negative 3 and negative 1, okay? So using your Inspire, it's a little bit different. So if you go to Document, New Document, all that, we add a graph. Let's do f of x equals, same function, x squared plus 4x plus 3, enter. So now, you can see pretty well that they're at negative 1 and negative 3, but let's say it doesn't fall somewhere nice. Well, and by nice, I mean on a line. Let's go to Menu, Analyze Graph, 0, because that's what we're finding. Let's start with the one on the left. So I'm going to click right to the left of it, right to the right of it. Oh, look, there's a 0, negative 3, 0. If I want to do the other one, Menu, Analyze Graph, 0, I'll go right to the left of this one, right to the left of the point, and then we end up with negative 1, 0 for our other point. Again, basically to do this, you go to Menu, Analyze graph 0, and then you have to choose a point to the left of the point you want and to the right of the point you want. Okay? So that's how that works. Either way, we end up, 1 second, sorry, I gotta flip everything around again. We end up with zeros at -1 and -3. Or again, you could write it as -1, 0 and -3, 0. Depends what the question is asking. Sometimes you're asked to write a quadratic function with x-intercepts. And again, this could be phrased as zeros, roots, solutions, all the same, remember. So write a quadratic function with x-intercepts at 2 and -5. Okay, well, in general, when you're writing a function, let's say it's f of x, we're just going to take x minus and x minus. So however many zeros you have, the zeros go right in there. So for this example, f of x equals x minus 2, there's one of them, times x minus -5, there's the other one. So I can simplify this to be f of x equals x minus 2 times x plus 5. Okay, let's solve y squared equals 81. Gut instinct might be 9, and you're half right. So if we literally solve this, y squared equals 81, if we take the square root of both sides, know that every even root has a positive and negative piece. So technically y is plus or minus the square root of 81. Square root of 81 is 9, so y is plus or minus 9. So depending on how you're asked to phrase it, I mean, you can do plus and minus 9. I think in the ALEKS assignment it might ask for them separately, I'm not sure. Otherwise, our answers are y equals 9 and y equals -9. Again, plus and minus 9, plus or minus on top of each other like this is fine. One more, slightly more complicated version of number 4. Let's solve c squared equals 50. Well, if c squared equals 50, we can take the square root of each side. So c is plus or minus the square root of 50. What is that? I don't know. But I do know I can simplify this square root, which we've done before, right? I can simplify it to plus or minus square root of 25 times square root of 2, since 25 times 2 is 50. So this is c equals plus or minus square root of 25 is 5 square root of 2. So c equals 5 root 2, and c equals -5 root 2. So your ALEKS assignment covers all of these. Again, it's just basically a review of what you can do with quadratic functions in terms of solving them.